Good day, geographers, and welcome to another lesson in our geography series. I am your lecturer, Donovan Aratri. Now, today we're going to be looking at weathering. Now, weathering is not what you think it is. If you think it has to do with the weather itself, well, no. But it has to do with the breaking down of rocks as a result of the various elements of weather being involved. So basically, the rocks are the main feature and not necessarily the weather. Now, let us elaborate some more on this word, weathering. So weathering is the process by which rocks gradually disintegrate or break down due to exposure to the agents of weather, which are temperature and water. We can also throw ice in the mix as well. All right. So denudation now is the process by which the Earth's surface is reduced by weathering and erosion. In other words, then, students, it is the process by which both weathering and erosion work together to wear down the Earth's surface. All right? And that is what we mean by denudation. Erosion takes the materials or the weathered materials that are broken down and move them by either the use of wind or water. And finally, deposition is when all the eroded materials or the materials that have been removed by either wind or water have been laid down or placed somewhere. That is what we call deposition. If you are trying to figure out what is the difference between weathering and erosion, it is just simply one word: movement. In weathering, rocks are simply broken down. Rocks are broken down in situ. In other words then, and situ is spelled S-I-T-U, in situ. Rocks are broken down where they are. So wherever the rocks are, they are broken down in that same location. However, when either wind or water have removed the rock particles, that is what we call erosion. All right. So with the difference between erosion and weathering, it is simply movement, because in weathering, rocks are broken down in situ, which means where they are, in the location where they are. All right. The word situ, that is where we get the word situation or place. So in the same place where they are, the rocks are broken down right there. However, erosion is where the movement of these broken down rock particles are now taking place. So either water or wind can remove these broken down or weathered rock particles. And that is the difference between weathering and erosion: movement. Rocks are broken down into where they are. That's weathering. But when they are removed by either wind or water, we call that erosion. So the erosion is where the movement takes place. Here we have rocks broken down like this. Now, here we have erosion taking place, where the rock materials are being removed. And in this case, what is removing the rock materials? Have a look. Good. It is water. I know you said water. If you didn't say it, you're thinking it. So it is water. What about this one? What is causing the movement of the rock particles? As you can see, it is the wind. So that is what erosion is. It is the movement of weathered particles, or should I say it is a movement of broken down rock particles by either water or wind. And that is the difference between weathering and erosion. Simple, one word, movement. Then now we go into the other part of weather or weathering. What are the three types of weathering? There are three types of weathering: physical, otherwise known as mechanical. And in mechanical or physical weathering, we have three processes that we are going to be focused on: frost action, otherwise known as freeze-thaw, temperature change, and pressure release. The second type of weathering is chemical weathering. Yes, we're going to do a bit of chemistry today as well. Basic, nothing too elaborate for you to manage. And in chemical weathering, we have four processes that we're going to focus on: hydrolysis, oxidation, solution, and carbonation. And the last part of weathering, or the last type of weathering, is biotic or biological weathering. And there are two things that are involved here. We have plant action and animal action. Yes, both animals and plants also aid or even participate in the direct breaking down of rocks. And we're going to look at all of these little by little. So now let us look at physical weathering. And the first process in physical weathering is thermal expansion, otherwise known as temperature change. All right, so how does temperature break down rocks? All right, so it is the process that mainly occurs in arid regions, such as hot deserts. Rock surfaces are heated up rapidly when exposed to the sun, and the surface layers expand and break away. At night, when the temperatures fall rapidly, the same layers contract or they shrink and develop more fractures or cracks. In time, the layers of rocks peel and fall off in a process known as exfoliation. And that is what we mean by thermal expansion, or otherwise called temperature change. Let me just put it to you another way. In hot areas, you see, students, temperatures are so hot that they cause rocks to actually swell. Rocks actually expand. Did you know that? They expand. Not so much that you can actually see it happening with your eyes, but very minute. All right? So it is a small growth, is a small expansion of the rocks. Not very obvious by the naked eye. But what happens is that because of the heat, the intense heat of the sun in these very hot areas, the rocks tend to expand slightly. And as they expand, they develop fractures or cracks. At night, when temperatures fall rapidly, they get very cool or cold, if you want to put it that way as well. And so what the coolness or the cold of the temperature does to the rock, it causes it to shrink. In other words, it gets smaller. As it shrinks, it also develops more fractures. And as this process repeats itself, expanding during the day and shrinking during the nights when temperatures fall, eventually the layers of the rock begin to peel off and fall off the rock like a tangerine or an onion. And that is what we call exfoliation, simply because the layers or the skin of the rock are gradually peeling away due to the constant expansion and contraction of the rock during day and night. And that is what the temperature does. It causes the rocks to expand during the day, which is the heat, the intense heat, and it causes the rocks to shrink at nights when the temperature falls or cools rapidly. Either way, you're going to have fractures or cracks developing in the rock surface or in the rock layers, and gradually each layer of rock is going to peel off and fall off the rock like an onion, or like what we know also in the Caribbean, tangerine, pegging the tangerine. Yes, that's how it works.
Mechanical weathering caused by thermal expansion and contraction. In areas with a large diurnal range of temperature, the rocks are heated up intensely during the day and cool to a low temperature at night. This results in an alternate expansion and contraction of the rocks. Thermal expansion and contraction results in three forms of mechanical weathering. They are block disintegration, granular disintegration, and exfoliation. Block disintegration occurs on rocks with cracks. Repeated expansion and contraction enlarge the cracks. Large masses split away from the main rock along main cracks. Rock breaks into blocks. Granular disintegration occurs on rocks with different minerals. Since different minerals expand and contract at different rates, rocks which are made up of a variety of minerals are under stress during alternate heating and cooling. For example, at daytime, mineral A expands faster than the adjacent mineral B and pushes them apart. During nighttime, mineral A contracts faster than the adjacent mineral B and becomes detached. Repeated expansion and contraction causes all mineral grains to loosen and detach. Rocks break off into grains. In time, rocks disintegrate into small pieces. Exfoliation occurs on a uniform mass of rock. During daytime, the outer layer absorbs more heat and expands more than the inner layer. Concentric cracks develop. At night time, the outer layer loses heat faster and contracts more than the inner layer. Radial cracks develop. Repeated expansion and contraction causes the outer layer to peel off. Rock breaks into slabs. A new surface is exposed to heating and cooling.
So here we have a diagram that is basically showing what you just saw illustrated a while ago. And so as you can see, the outer layers are flaking away or peeling off, just like what you saw in the diagram, or should I say in the video, as a result of the expansion and the contraction of the rocks. And this is what we call exfoliation. And as human beings, our skin exfoliates because our skin strips. Whenever our skin is stripping or shedding old skin, that is what we call exfoliation. In the very same way for the rocks, its layers also exfoliate because of the constant contraction and expansion of the rocks, which over time creates fractures, and eventually they flake off or peel off. So here we have it in motion again, the outer layers of the rocks gradually peeling off just like the layers of an onion. And that is what we consider to be exfoliation, all because the heat is causing the rocks to expand and contract during the day and night due to rapid cooling, and therefore developing cracks, which eventually over time allows for the outer layers of the rocks to peel off. So here we have a rock that has been exfoliated. There's the area encircled where the outer layer have been exfoliated or peeled off. Here's another one, and there you can see the layer being peeled off as well, or exfoliated. And here we have another form of exfoliation taking place due to the constant expansion and contraction of the rock. Now, frost action occurs in areas that are extremely cold. What tends to happen is that during the day, water collects in the pores or cracks of the rocks, and in the night, the water freezes as a result of rapid cooling. Now, the thing about ice is that it expands, so naturally, the ice in the cracks are going to expand, causing the cracks to get wider and deeper. In the day, the water melts and more water is collected. Thereby, in the nights, this water once again freezes and contracts, and thereby causing the rock to split apart. Now, the ice actually creates a wedge in the fractures or the pores in which it is expanding. Thereby, over time, the constant melting and collecting of water and freezing of water at nights causes the rocks to eventually break apart. That is what we call frost action. Here we have two specimens of rocks, one to the right, one to the left. The one to the left is filled with water in the crevices or the cracks. Now, at night, the water freezes, causing the cracks to get wider and deeper. And as this process repeats itself over and over, eventually over time, the cracks get wider, it gets deeper until it breaks off completely.
Freeze-thaw action. Freeze-thaw action occurs high up in mountainous areas where there is lots of precipitation, rain, sleet or snow. During the day, water seeps into the cracks in the rocks. At night, if temperatures fall below freezing point, the water in the cracks freezes and expands, putting pressure on the rocks. Over time, this process continues to occur, weakening the rock and eventually forcing a piece of it to break off. The broken down rock then gathers up and is known as scree. There is usually a build-up of scree at the base of the slope.
All right, now here is a rock that was actually broken up by frost action. So here you can see the wedge here, and here's another one right here. All right, so that was as a result of the same process that was illustrated to you earlier on. Yes, next is pressure release. Now, pressure release is actually a process of weathering that happens like this. All right, students, now listen carefully. What tends to happen is that there is a layer of rock beneath the Earth's surface. All right, now the weight of the Earth's surface places a lot of pressure or weight onto the rock layer below. Now this prevents the rock layer beneath the Earth's surface from expanding. Now, over thousands of years, the Earth's surface that is covering this layer of rock eventually gets eroded. And as it is eroded, it exposes this layer of rock that is beneath the Earth's surface. Now, as a result of the release of the weight or pressure that once exerted on this layer of rock, right? Because the earth layer has been removed, the weight or the pressure that it exerts on the rock have been removed. Now, because it has been released, it causes the rock that was once beneath the surface to expand. And as it expands, it opens up fractures or cracks. Now this will allow for other processes of physical weathering to take place on this rock. Say for example, frost action, where water can get into the pores or into the rocks, cracks that have been opened up as a result of the pressure being released or the rock being expanded. And you know the process, it will gradually repeat itself, freeze and melt, and every time the water freezes, it expands and open up the fractures more. Hence you will have the rocks breaking off. It can also, because of pressure release, you may also have thermal expansion or temperature change acting on the rock. So because the rock has now expanded, during the day it will get larger or expand, so it will develop more cracks, and in the night it will shrink and develop more cracks as a result. And this constant shrinking and expansion of the rock due to the change in temperatures, you will have the rock surface peeling off. Again, that is called what? The peeling off of the rock surface layers is known as exfoliation. Alright, so that tends to happen, or it can break up in other ways as a result of temperature change. Alright, so what pressure release does, students, is that the layer of the rock beneath the surface is actually covered by another layer of the Earth's surface, and the weight of the Earth's surface puts a lot of pressure on the rock, so it doesn't allow for the rock to expand. Now over time, the layer of the surface that is on top of the rock is going to be eroded, and as it is eroded, it is going to expose the layer of the rock that is underneath to the surface. Now, because it is now exposed to the surface, it is going to start to expand because the pressure that was on it has now been released. So because of this release of pressure, the rock that was once under the surface now starts to expand. And as it expands, it develops cracks. Now this will allow for frost action to take place and influence the weathering process further. All right, if it's in a cold climate where the water will collect in the cracks during the day and freeze and expand in the night, and then melt again in the day, and in the night it will collect more water in the day and will expand and freeze in the night, causing the cracks, eventually causing the rocks to break off. If it's in a arid area that is this pressure release has occurred, then you will have the rock expanding and creating more cracks during the day because of the intense heat of the sun, and it will contract at night or shrink because of the rapid cooling, and therefore it will develop more cracks. And this continuous expansion and contraction of the rock creating more cracks will eventually cause it to peel off. Have a look at this, students. Here's a diagram showing the layer of rock. All right, let me get my laser here. So here we have our layer of rock on the surface, and beneath it we have a layer of rock known as granite, all right, being buried. Now this layer of granite is under a lot of pressure due to the weight of the surface layers up here. Good. Now when the surface layer have been eroded and eventually removed, exposing the rock to the surface, guess what? The rock now begins to expand because all that weight that was putting a lot of pressure on it has now been removed and has released all the pressure from this rock. So the rock begins to expand. As this rock expands, it tends to be acted upon by other agents of weathering. For example, thermal expansion, where the heat of the sun causes the rocks to expand and Because of the cooling effect of it at night, it causes the rocks to also shrink. So it eventually continuously shrink and expand, creating all these cracks. And then you notice the layers are peeling off layer by layer. So we have exfoliation taking place. In areas that are very cold, you may have freeze thaw or frost action taking place, whereby the water goes into the layers or into the cracks right here, as magnified up here, and at night the water freezes and expand, creating larger cracks. And the more this continues to go on, you will have the rocks peeling off, hence pressure release. Weathering. Here we have a layer of rock that has been exposed to the surface, and because it was exposed to the surface, it has been acted upon by thermal expansion in this case. So you notice the rock layers are peeling off like that of an onion. Okay, so that was physical weathering. And as you remember, we looked at all the different processes in physical weathering: frost action, pressure release, and thermal expansion. Now we're going to deal with biotic weathering / plant action, because you see, biotic weathering is actually weathering by either plants or animals, or the breaking up of rocks by either plants or animals. In this case, we're going to look at plant action. So how does a plant actually break up rocks? Well, really and truly, students, you do have rocks beneath the surface, usually beneath where plants are located. Now, as the plants grow, it tends to force its roots downwards into the pores or cracks of the rocks, because it's actually seeking water. Over time, these roots expand, and as they expand and get deeper, they create a wedge into the rocks, causing the fractures or the pores to get larger. Hence, over time, it will force the rocks apart. You didn't think that plants are so powerful? Well, now you know. They can actually do this by forcing their roots into the rocks, whether through the cracks or the pores. And over time, as the plants develop and get bigger, the roots also expand, causing the fractures or the pores to expand and forcing the rocks apart. So there's a wedge being created in the rock, causing it to break apart. And this happens quite a lot, especially here in the Caribbean. So here we have a demonstration. You can see in the diagram where the roots of the plants are forcing their way into the crack, and as the plant roots gets wider and deeper, it forces the rocks even further apart, and eventually over time it will break the rocks apart. Here we have a photograph of a tree root forming a wedge in a rock and forcing it apart. Now that's biotic weathering via plant action right there for you. There's a root. So besides plants, animals also directly or indirectly influence the weathering of rocks. Now, burrowing animals like worms, ants, rabbits, all those other animals that actually tunnel underneath the surface. Well, whenever they are digging or tunneling under the ground, they tend to use their paws and break up rocks directly. So directly impacting or directly breaking up rocks as they are digging through the ground. So they'll actually use their claws or pause, I should say, and break up the rocks as they are digging further and further down into the ground. They also allow for other agents of weathering to have direct access to the rock. For example, as rabbits or even ants make their way under the surface, as the rain falls, the water will actually go underneath and go into these burrows or tunnels that these animals have created, thereby having direct access to the rocks beneath the surface. Now, this can influence another type of weathering, and this is what we call chemical weathering, which has several processes of its own depending on the nature of the rock. So because the rocks have now been exposed underneath the surface because of the burrowing action of the animals like the ants or the rabbits, for example, the water can easily go into these tunnels that they have created and have direct access to the rocks and can further break them down by means of chemical weathering, right? So a lot of the times when you see an ant's nest, for example, some of that material that you see making up the ant's nest are fragments of rocks that the ants have actually broken up and pushed out to create their nest. You'd also have an animal like a snail. Yes, snails can also impact the breaking down of rocks. I don't know if you ever noticed this when you see a snail just on a rock. All right, what the snail is actually doing is feeding, because the rocks contain minerals. Now these rock minerals are soluble. That means they can be dissolved easily, especially when exposed to acid. Now the slime that these snails have are very acidic, and they will actually sit on the rock and absorb the minerals, especially if the rock have mineral salts in them. And as they are doing it, they are dissolving the minerals. As they dissolve the minerals, they actually cause the rock structure to be very weak and allows the rock, make the rock prone to be broken down by other agents of weather like heat, or should I say temperature, and water as well. So the snails also play an important role in breaking up rocks, because what they do, they actually dissolve the minerals from the rock by licking them or absorbing it. And as the minerals from the rocks have been dissolved, it causes the rocks to be very weak. And eventually, over time, the rocks can break down as they have become prone to attack from other agents of weathering, such as water and temperature. Now, here we have an example. This is a burrowing animal's hole. Could be a rabbit, I'm not sure. And as you can see, some of the rock fragments on the outside. Here we have an ant's nest, and if you look carefully, you also see rock fragments on the outside as well. And as the rain falls, the water will go into these tunnels and get direct access to the rocks, causing chemical weathering. And that is along with the fact that the ants, as well as the rabbits too, already break up the rocks underneath the surface. Here we have a worm again, also another burrowing creature, and this burrowing action of the worm also allows for water to go beneath the surface. Now, whenever plants and animals die, what tends to happen is that when they are decaying, they release an acid known as humic, H-U-M-I-C, humic acid. Now, this humic acid is very powerful because it will act on the minerals in the rocks and causes them to break and causes the rocks to become weak, and over time causes the rocks to break down. All right. Here we have a microscopic plant, more like a fungi. This is known as a lichen, L-I-C-H-E-N, and it actually acts upon the minerals in the rocks. Now, as I said earlier, when the minerals of the rocks are under attack or have been dissolved, it only allows for the rock to become weak in structure and become more prone to being broken down further by either water or temperature. You see, students, what I'm trying to show is that the minerals in the rocks are like the steel that are in the walls of houses. All right, without the steel within our houses, what tends to happen is that during an earthquake, the houses will actually crumble. It is the steel that actually holds up the structure. In the same way, the minerals hold up the structure of the rock. Without the minerals, they will cause any type of agent of weather can easily break down the rock. And finally, there you can see a snail on a rock actually feeding off the minerals on the rock, which eventually cause the minerals to dissolve and helps in the rock getting weak over time and eventually becoming prone to being weathered by either frost action or some other form of physical or even other forms of chemical weathering. Alright, so now that we have completed physical weathering and biotic weathering, we are now going to look at chemical weathering, which is the last of the three processes of weathering. Now, this is where we delve in the realm of chemistry. Basic chemistry, but nonetheless, we can get through this, alright? So make sure you pay keen attention as to what we are dealing with here. Now, chemical weathering is the chemical decomposition of rocks as the minerals react with water. Let me just make something clear. In chemical weathering, the minerals that are in the rocks, once they react with water, they are changed into another compound. And usually the compound in which they are changed are not as strong as they were as the minerals were in their original state. It actually changes them to weaker compounds. And because of that, you tend to have the rocks being prone to weathering or chemical weathering or even weathering by other agents outside of chemical weathering. Let's delve in a little bit, shall we? Now, students, the first process of chemical weathering is oxidation. And this is basically where oxygen in the water reacts with the iron that is in the rock. Yes, rocks contain iron. Iron is a mineral. What you need to understand, students, is that rocks are actually hard-body materials composed of minerals. And one of the minerals that can be found in rocks is iron. Now, whenever iron interacts with the oxygen that is in the water, it creates what we call rust. Just like when you see metals become rusty, yes, that actually happens in rocks. Now, think carefully if you have ever, in any time in your life, actually encountered a rock that seemed to have rust on it. What you have observed is oxidation of the mineral iron that is present in the rock. So, what is oxidation? Well, oxidation occurs when oxygen is dissolved in rainwater and reacts with the rock minerals to form a compound which disintegrates or breaks down the rock. In this case, rainwater will react with the mineral iron to form a reddish-brown compound known as iron 3 oxide, which we commonly call rust. Now, rust disintegrates the rock. In other words, it breaks down the rock. You see, students, iron 3 oxide is a weaker form of iron, and therefore it is unable to keep the rock structure strong. Therefore, once the iron is converted into iron 3 oxide, it means that the rock structure is very weak, and therefore in time the rock itself will break down. Now class, I'm sure there's a time, if it have never happened to you before, but I'm sure there's a time that some of you may have experienced this, where you probably stepped on a rock or even picked up a rock and break it with your own hands, with your bare hands. Why? Because the rock is weak, and it's usually during the oxidation process that the rock becomes very weak. Now, without the mineral iron, the rock structure is very weak, and it means therefore other elements of weather is going to act on it and therefore cause the rocks to get weak. So you can easily at times pick up a rock and break it with your own bare hands, or even step on it and it breaks easily or crumples. All right, now that is what tends to happen with rocks that undergoes oxidation. Let's delve in a little more in chemistry. So oxygen reacts with iron that is already in the rock. So the oxygen in the water reacts with the iron in the rock to create iron 3 oxide, otherwise known as rust. Now this, as I said, is a very weak compound. It is not as strong as iron, it's extremely weak. So because it is so weak, it cannot hold up the structure of the rock. So the rock becomes very weak, very brittle, very fragile, I should add. And therefore, the rock is easy to break down by other processes of weathering. Like, for example, physical weathering, freeze, thaw, temperature change, or even thermal expansion, right? These can easily act upon the rock and easily break it down. And as you notice, or you probably have experienced that sometime before in your life, you probably have stepped on the rock and it breaks, or you pick it up with your hand and it easily breaks, or maybe you dropped it and it just easily breaks. And you look inside of it, or on the outside, sometimes you see rust on the outside. Now that is what oxidation does to the rock. So here we have a rock that is undergoing oxidation. Just put a little bling bling effect there just to highlight the iron compounds, all right, that are on the rock. So that rock is actually undergoing oxidation. As you can see, the rust on the outer layer being exposed. Over time, that rock itself is going to break down under other forms of weathering. So here we have the edges of the rock here being oxidized. Here we have oxidation around the rim of that piece of rock there as well. So that was oxidation. Now let's move into carbonation, which is the next process in chemical weathering. So carbonation is the reaction of carbonate with minerals, which may dissolve as a result. Rainwater combines with carbon dioxide to produce a weak solution called carbonic acid, which aids in the carbonation process. The weak acid solution causes limestone rocks to dissolve and be removed as calcium bicarbonate. Now this calcium bicarbonate this causes the rock's surface to become pitted with sinkholes as well as clints and grikes. Okay, let me explain this. You see, students, carbonation only takes place with limestone. Carbonation only takes place with limestone. and I'll explain why. As the rain is falling through the atmosphere, it mixes with the gas carbon dioxide. Now this converts the water itself into a weak acid known as carbonic acid. Now the carbonic acid reacts quickly with limestone. All right. Now the calcium carbonate, that is limestone, all right, reacts with the carbonic acid. You see, the carbonic acid will dissolve, or should I say convert, the limestone, which is calcium carbonate, into calcium bicarbonate, which is a weak compound. Let me repeat. So as the rain falls through the atmosphere, it mixes with carbon dioxide to create a solution known as carbonic acid, which is a weak acid. Now the carbonic acid will react with the calcium carbonate, which is what we call limestone. Now the calcium carbonate is going to be changed into calcium bicarbonate, which is a weak solution. All right, so as it interacts with the carbonic acid, it turns into calcium bicarbonate, which is a weak solution, and that is how the carbonic acid dissolves and removes the limestone, or weathers the limestone, by converting it to a weaker compound known as calcium bicarbonate. So the calcium bicarbonate becomes removed by the water, and depending on where on the limestone surface, you may have features like sinkholes being formed or cliffs and grikes also being formed. All right, and that is how carbonation works. Here is so here we have carbonic acid, which is the formula, which has a formula H2CO3. That is the formula for carbonic acid. Now it reacts with calcium carbonate, which is the other name for limestone. Yes, so calcium carbonate, CaCO3, is the other name that we give to limestone. All right, it's a chemical name for limestone. So when carbonic acid reacts with calcium bicarbonate, or the limestone, it converts it or turns it into calcium bicarbonate, which is more of a hydrated or a wet form of calcium hydrogen carbonate. It's a weaker solution than limestone, and that is how the water actually removes or weathers or breaks down the limestone rocks. It has to first of all convert the limestone, which is calcium bicarbonate, into calcium carbonate into calcium bicarbonate, in order to effectively weather the limestone. All right, students, so let me repeat. The carbonic acid reacts with the calcium bicarbonate, which is limestone. It turns the calcium carbonate into calcium bicarbonate, which is a weak solution, and that is how limestone is weathered by carbonation. And that is how the process of carbonation works. When carbonic acid, which is a weak acid, which is actually a combination of water and carbon dioxide, to turn calcium carbonate or limestone into calcium bicarbonate, which is a weaker solution. And that is what happens in carbonation. So limestone is turned into calcium bicarbonate. That is how it is actually weathered in carbonation. So here we have a limestone pavement, and in this limestone pavement we have rocks. Now these rocks that we see here are called the clints, and the space between them are the grikes. So that space there that is between the rocks, what do we call it? I hope you've been listening. The space between the rocks is known as the grikes. Okay, here's another one. And here we have the rock. The rock itself is what we call clints, because we have fractures in the rock. So as the water is flowing on the surface, it will eventually convert the limestone into calcium bicarbonate, which is a much weaker solution. and as it converts it into calcium bicarbonate, that is how it actually removes it, because it's weaker, so it's easier to remove. And that is how weathering takes place in limestone areas. And remember, there's another clint as well. So all those rocks are the clints, and the space between them are the grikes. So remember, students, in carbonation, it only happens in limestone, or it happens on limestone rocks, in limestone areas. All right, and that is why we have other features like caves and sinkholes as well. Here we have a sinkhole coming into view in its younger stage. That is because of carbonation. Once again, the carbonic acid, which is the rainwater combination of the rainwater carbon dioxide combination, turning the limestone, which is calcium carbonate, into calcium bicarbonate, and eventually dissolving it or removing it. So you have these pothole looking features in the limestone area. And as it gets deeper over time, it will create sinkholes, or swallow holes as we call them. We have plenty of them in Jamaica. All right. So there they are, as I'm circling a few of them. Some minerals in rocks are very easy to be dissolved. In other words, then, they are soluble. So as soon as they interact with the carbonic acid, they are dissolved. Like, for example, rock salts. Yes, most minerals are easy to dissolve once they interact with carbonic acid. Remember what carbonic acid is? Basically, it's a solution created by the mixture of rainwater as well as carbon dioxide. Right, and that is a weak acid. So it doesn't only act upon limestone, right, which is actually what we call carbonation, but it also dissolves minerals. And when it dissolves minerals, the rocks become deprived of these minerals, because the minerals allow the rocks to be strong, to have a very sturdy or strong structure, so that they don't break down very easily. All right, so think about it this way. The minerals are like the steel rods in the walls of the houses, right? That basically keeps the house sturdy. Without them, so during the time of an earthquake, for example, or maybe a very powerful hurricane, the structure of the house can withstand these vibrations or powerful hurricane winds, right, or forces. However, if the walls do not have steel rods in them, an earthquake can easily cause the structure to tumble down, or even a very powerful Category 5 hurricane can even cause the walls to cave in as well. So without the steel rods, that is what's going to happen. It's the same thing with the minerals in the rocks. The minerals are like the steel rods in the rocks. They keep the rocks sturdy and strong so that they can withstand all other types of weathering. So without them, when the water or the carbonic acid dissolves the minerals in the rocks become weak. So now they are prone to being broken down by either thermal expansion or even frost action. All right, and that is one of the reasons why minerals are important to rocks. But because of solution, rocks are deprived of minerals because the minerals are dissolved, and therefore the rocks become weak. So just think of salt, for example, being dissolved in water. That's what happens whenever salt, or should I say all other rock minerals, interact with the carbonic acid. Now the next And the final chemical weathering is hydrolysis. Hydrolysis is the disintegration of rock minerals by hydrogen ions in the water. Hydrogen ions in the water. All right, let's delve a little further. This occurs when the hydrogen ions present in the water reacts with the minerals in the rocks to change the minerals into weaker and softer compounds, which causes the rocks to break down over a period of time. For example, changing the mineral feldspar to clay. Okay, so let me just explain to you what you have just read. There are ions in the water, all right? And these are what we call the hydrogen ions. Now, whenever the hydrogen ions interact with minerals in the rocks, it tends to remove them or dissolve them, and then as a result of these ions, or should I say the ions displacing or removing the minerals in the rocks, the rocks minerals eventually change into another compound which is usually weaker or even softer than the original mineral. And we gave one good example a while ago. Feldspar is a type of mineral that whenever it comes into contact with hydrogen ions in the water, it automatically is replaced. Its particles, or should I say its minerals, are replaced, and therefore because its ions have been replaced, it changed into another compound, and this compound is what we call clay, or specifically China clay, otherwise known as kaolin. All right, so that's what really happens in hydrolysis, because the ions in the water, the hydrogen ions in the water, basically displace the original minerals or their ions, and as a result you tend to have new compounds being formed, but it's a much weaker compound than the original mineral that was there. So the rock becomes extremely weak, and as the rock becomes weaker, it is more prone to being broken down by other elements of weather or other agents of weathering, and we already know them, right? Like temperature, frost action, as well as what? Okay, so you already figured them out, right? Good. So basically that is what hydrolysis is all about. Let me go a little deeper with you. So here we have the water or the rain falling, and the water seeping through the soil, making contact with the rocks. Now the water itself is being absorbed by the rocks. As it is absorbed by the rock, in this case granite, it will actually interact with the feldspar that is in the granite. Now the feldspar ions are actually dissolved, and because it's dissolved, it changed into clay, a new type of compound or mineral, and we call that clay. And clay is much softer, and if the clay is softer and much weaker than the original ions that were in the rock, what's really going to happen here now, students, is that the rock itself is going to become weaker, and over time it will break down, all right, because it is not strong enough anymore. It has a weaker compound to replace what was once there, and therefore it's going to actually break down over time, given the right conditions. Now class, here we have feldspar, which also goes by the name potassium aluminum silicate oxide. All right, That is the chemical name for it. And it interacts with the hydrogen ion in the water. Now, when it interacts with the hydrogen ion in the water, it becomes this. It becomes China clay, otherwise known as kaolin. Now, that is because the iron oxide, or should I say the hydrogen ion, converted the ions in feldspar, removed them, and therefore it develops a new type of compound as a result, which is much softer and easier to crumble or break down, and that's what is the clay. All right, and that's the formula for kaolin or China clay. You have other forms of feldspar as well. In this case, we have potassium aluminum silicate oxide, but you also have calcium aluminum silicate oxide, and we also have another one, sodium aluminum silicate oxide. Those are the three forms of feldspar. Good. And all of them basically give you the same result once they have been interacting, or they are reacting with the ions or the hydrogen ions that is in the water. All right, they become clay, some form of clay. In this case, we have kaolin, which is China clay, which is a little different from the other two types of clays that would have been formed from the other two types of feldspar. So with that, geographers, comes the end of our lesson. I really hope you enjoyed it, and it was my pleasure in presenting this topic to you. So remember to hit the like button, hit the subscribe button, also hit the notification button so that every time I release new content you will be notified. All right, so thanks again, geographers, for visiting my channel and visiting and accessing this video. I really appreciate it. So take care, everyone, and keep loving the subject of geography and continue to work hard. Have a great day.